Welcome to the ISACA chapter for Washington, D.C. Metro Area YouTube channel. This is part of our Cybersecurity 101 series, and in our first topic, we're going to be looking at how symmetric encryption works. So Bob would like to get a secret word over to Alice. That secret word is password. Now, if he just sends it over to Alice, obviously anybody that sees it is able to read it. So what he needs to do is he needs to take the word password and alter it in some way. So he's going to take password, he's going to encrypt it, and then send over SDVV, the ciphertext. The only problem is, when Alice gets a ciphertext, she's like, SDVV, what does that mean? So Alice needs to know what Bob did to the word to be able to reverse out of the process. So Bob took the word password and he actually took each alphabet and he moved it on by 3. So he moved each alphabet. So a P became a Q, R, S, moving it over by 3, and A becomes a D, and S becomes a V, and so on. And then he sends it over to Alice. Alice simply needs to reverse that math, applying the same key, which was 3, and out comes a plain text. And that is how symmetric encryption works. The same key is being used to encrypt the text as unencrypt the text. So, all encryption will have in common some form of math. And that math, that algorithm, is actually published. So one of the most common ones, Advanced Encryption Standard, AES, also known as Randall, is one of the best known symmetric encryption algorithms. AES was adopted by the US federal government as a standard in 2002 after approval by the US Secretary of Commerce. It's used to encrypt much of our data today. Two-fish is another common symmetric encryption algorithm, and there are many, many more. Now, the key space is the number of values, that you have to guess to be able to just crack the key. So in our case, where Bob was using the alphabet and just moving it over, there's only 26 alphabet. So it's not going to take you very long to be able to guess. So the key space is very small. The most common key sizes are much, much larger, 128 bits, 256 bits. An 128-bit key means that in order to guess the key, it would take me 2 to the power of 128 guesses, which is a very big number indeed and would take millions of years to guess given our current computing power. Guessing the key is called a brute force attack, and it's important that the way the key is derived is truly random, or it may require less guesses to be able to crack the key. So we see that Bob takes the word, the plain text, applies some math and a key, encrypts it, sends over the ciphertext, and Alice simply reverses the process with the key. So the challenge with symmetric encryption is, how does Bob and Alice agree on a key without, and you'll see the green character in the back, that's Fred, without Fred overhearing the key? Because the math, Randall, AES, Two-Fish, all the math is well known. We all know the algorithms. The only thing we don't know is the key. So if Fred has the key, he too can unencrypt the word and come back to the plain text. So in Series 2, we're going to be looking at asymmetric encryption. And that's what we use for being able to get the key over securely to the other side. And that challenge enables Bob and Alice to share the same key without Fred finding out what that key is. Thank you so much for watching the first in our series on cybersecurity fundamentals. Please do follow us on Twitter. Both our Twitter handles are there. And read our newsletter for all information on ISACA DC. Thank you.